DBS 10012 Engineering Science Mini Project Understanding Energy Conservation in a Skateboarder Simulation Season 2 2024 or 2025. Presented by Nur Farhana Atika binti Yuslim, 14 DKA 23F 2011, Farisha Tasnim binti Fazrul, 14 DKA 23F 2003. Energy have a three. The first one is potential energy, second is kinetic energy, and last is total energy. Kinetic energy. Kinetic energy is the energy of motion depending on the speed of the object. The formula is Ke 1/2 mv, where m is mass and v is velocity. Kinetic energy. Next is potential energy. Potential energy is the energy stored in an object due to its position in a gravitational field. The formula is Pe mgh, when m is mass, g is gravity, and h is height. For the example, skateboarder is a maximite depending on their height above the ground. Total energy. Total energy is the sum of potential energy and kinetic energy at any point. The formula is the total energy equal to potential energy plus kinetic energy. In a closed system without external force like friction, the total energy remains constant. Through the skateboard's journey along the track, the total energy remains constant, demonstrating the conservation of energy. This is an example for energy. The first one is top of first hill. Here, at the top of the first hill, the skateboard's speed is 0, so kinetic energy is 0, and potential energy is at its maximum. The second one is midway downhill. As the skateboard descends, their height decreases, reducing potential energy, while kinetic energy increases due to the acceleration. The third is bottom of valley. At the lowest point, the potential energy is at its minimum, but the kinetic energy is at its maximum, maintaining the total energy. The last one is top of second hill. Climbing up the second hill, we see a similar pattern where potential energy increase and kinetic decrease with total energy remaining constant. So, this is an objective for energy. The objective is determine potential energy, kinetic energy, and total energy using PHE's energy skate park simulation.
At point A, the skater is at the highest point. Here, potential energy is at its maximum, while kinetic energy is minimal because the skater's speed is very low. At point B, as the skater descends and climbs again, some potential energy is converted into kinetic energy. The skater gains speed but slows down slightly as they reach the next peak. At point C, at the lowest point, potential energy is at its lowest, and kinetic energy is at its maximum. The skater moves the fastest here. At point D, moving uphill again, kinetic energy is converted back into potential energy. The skater slows down as they climb. At point E, similar to point C, potential energy is minimal, and kinetic energy is at its peak. The skater's speed is highest at this point. 1. Point A, height equals 6 m. The object is at its highest position with maximum potential energy, 3531.6 J, and no kinetic energy, 0 J, indicating it is stationary. The velocity at this point is 0 meters per second. 2. Point B, height equal 4 m. As the object descends, some potential energy is converted into kinetic energy. At this height, the potential energy has decreased to 2354.4 J, while the kinetic energy has increased to 1177.2 J. The object is now moving with a velocity of 6.26 meters per second. 3. Point C, height equal 2 m. The object continues to fall, losing more potential energy, 1177.2 J, while gaining kinetic energy, 2354.4 J. The velocity at this point has increased to 8.86 meters per second. 4. Point D, height equals 0 m. The object has reached the ground level, where its potential energy is 0, and all of it has been converted into kinetic energy, 3531.6 J. The velocity is at its maximum, 10.85 meters per second. 5. Point E, height equal 1 m. This is a point just above ground level where the potential energy is low, 588.6 J, and most of the energy has been converted into kinetic energy, 2943 J. The velocity at this point is 9.90 meters per second. GY, demonstrating the conservation of energy.
Discussion: the constant total energy throughout the skater's movement confirmed that the principle of conservation of mechanical energy, objects in free fall, convert gravitational potential energy into kinetic energy. Dropping an object from a height demonstrates the conversion of potential energy to kinetic energy. Conclusion: understanding this energy interplay helps explain the skater's acceleration, speed changes, and how energy influences their motion on ramps. A skater at the top of a ramp has maximum gravitational potential energy, which converts to kinetic energy as they descend, increasing speed. Throughout the motion, total energy, kinetic plus potential, remains constant, illustrating energy conservation. This energy transformation helps us understand the skater's motion dynamics and the principle of energy conservation in action.